So before you all start today's classwork, I want to start by doing a warm-up. If you didn't watch the Day 5 video, you should be doing that now. If you did watch it, please take out your note packet, so the green packet, and turn to the very back. Very back should be blank except for a few other warm-ups that we've done. So we're going to do one warm-up together and then you'll start working on your classwork. So right now we're going to do one graphing example together. I want to graph y equals x squared over x squared minus 4. So we're going to graph it and then we're going to find everything you had to find in the video. So in the video you had to find the x-intercept, you had to find the y-intercept, you had to find the vertical asymptotes, you had to find the horizontal asymptotes, you had to find the domain, and you had to find the range. So we're going to find all of that. So my first suggestion when you're doing problems like this is anytime that you need to factor, start by doing that. So in this case, the denominator factors. Numerator, just leave it, it's only one term. X squared minus 4 factors to x minus 2, x plus 2. Okay, so then your x-intercept. X-intercept means that y is 0. Okay, so if we set our y equal to 0, that means that the numerator is 0. So the only way for a fraction to be 0 is if the numerator is 0. So in this case, we get x equals 0, which means that x is 0. For our y-intercept, that only happens when x is 0. So we need to plug in a 0 for x. We get 0 over negative 2 times positive 2. 0 over negative 4 is just 0. Okay, now one thing I want to point out, it is not always the case that your x and y-intercept are going to be the same. That's actually pretty rare. So while it happened here, that's not always the case. Okay, so moving on to find our vertical and horizontal asymptotes. Vertical asymptote happens when the denominator is 0. So that's not allowed. You're not allowed to divide by 0. That's why you end up with an asymptote. So we get x minus 2 times x plus 2 is going to give us 0. That means we have two asymptotes at 2 and negative 2. Now please remember that asymptotes are lines. So you have to write x equals. That indicates that you're talking about a vertical line. If you just write 2 or negative 2, that's going to be wrong. Now, horizontal asymptote, that's when you look at the degree of the numerator and the degree of the denominator. By degree, I mean the highest power. So the highest power in the numerator is 2 from the x squared. In the denominator, the highest power is also 2 from the x squared. In this case, our numerator and denominator have the same degree. So what you do in that case is you look at the coefficients of the numerator and the denominator. So the coefficient of the numerator is a 1x squared. Coefficient of the denominator is 1x squared. So we get our y to be 1 over 1. So our horizontal asymptote is at y equals 1. Instead, let's say we were looking at 2x squared over x squared minus 4. So again, the powers are the same. This time, look at the coefficients out in front. So we would get 2 over 1, which would give us a horizontal asymptote of 2. Again, this is only the case when the numerator and denominator have the same degree. If we were looking at y equals x over x squared minus 4, in this case, the numerator has a smaller degree than the denominator. The numerator has a degree of 1, whereas the denominator has a degree of 2. Anytime the numerator is smaller, you're going to get y equals 0. So these were things that you got in the video, just to refresh your brains. Okay, domain and range I always want to do at the end after I have my graph. So what I want you to do right now is draw yourself out a coordinate plane. Okay, so now I'm going to graph in my asymptotes. So remember that they're going to be dotted lines. So remember, your graph never touches the asymptote, it never crosses the asymptote. Instead, it's going to hug the asymptote at some point. So your vertical asymptotes are what break up the graph. So we're going to have 3 parts to a graph. Part here, a part here, and a part here. So the left of the first asymptote, the middle of the 2 asymptotes, and then the right. So in order to figure out what those parts look like, we're going to have to make ourselves a table. You're always going to put both asymptotes, so negative 2 and positive 2, and then you want to know the behavior around those. So I'm going to choose negative 3 and negative 4, positive 3 and positive 4. Now in the middle of the negative 2 and the positive 2, I'm going to actually choose 3 numbers so I can really get a good idea of what that one looks like. And then you guys start plugging in. If you take the negative 4 and you plug it in, you get 16 over 16 minus 4. So that's going to be 16 over 12, which simplifies to 4/3. If you look at the negative 3, if I square the negative 3, I get 9, and then I get 9 minus 4, so that'll be 9 over 5. Remember the asymptotes you can't plug in. They're going to make the denominator 0. Denominator can never be 0. If I plug in negative 1 squared, I get 1 over 1 minus 4. So this is negative 1/3. Sorry, that should be a 3. If I plug in 0, I'm going to get 0. Now here's what's interesting. Let's plug in 1 again. Positive 1 this time. When I plug in positive 1, I still get 1 over 1 minus 4. So I still get negative 1/3. Now, why does that happen? Well, you're squaring, and then you're squaring again. So the sign doesn't matter. So likewise, when I plug in 3, I'm still going to get 9/5, like I did with the negative 3. When I plug in 4, I'm still going to get 4/3, like I did with the negative 4. Now, if you still want to plug them in, you can, but that's what you're going to end up with. So now we need to go to graphene. Okay, so negative 4 and 4/3. 4/3 is just a little bit bigger than 1, so that's about here. Negative 3 and 9/5. 9/5 is almost 2, because 10 over 5 is 2. So what we see is we have something that looks like this. Again, it's going to hug your asymptote. So it's hugging the vertical asymptote and it's hugging the horizontal asymptote. Okay, so with the negative 1, we get negative 1/3. So that's like here. And then 0, 0, and 1 end, negative 1/3. So here's what this graph is going to look like. Again, normally you won't touch the asymptote. In this case, we do. But most of the problems you do in class, probably all of them actually, you're not going to touch the horizontal asymptote. This is just an exception. Okay, so then when I plug in 3, I'm going to get 9 over 5 again. So really close to 2. When I plug in 4, I'm going to get 4/3, so a little over 1. So then this is what my graph is going to look like. Okay, so that's what the graph looks like. So again, we have the 3 parts of the graph on each side of the asymptotes. So we're almost done. I know this has been a long warm-up. Last thing we need to talk about is the domain and range. So domain always stands for x. X is your left, right. So you're going to notice the x forever goes in the left direction, forever goes in the right direction. So that's all real numbers, but it never touches the asymptote. So it can't be -2 or +2. Range is the y's. It's forever in the up direction, forever in the down direction. So our graph goes down forever, doesn't go up though. So what you're going to see is that y is less than or equal to 0. Normally though, it won't touch the asymptote. So again, just remember, normally your graph is not going to touch the asymptote. So like we've talked about before, domain and range you cannot memorize. You have to look at the graph, and that's how you figure out the domain and range. So I hope this clarified any misconceptions that you might have from the video or any questions that you have. Whatever you can't finish in the classwork, just remember that I will be here tomorrow. Good luck.